Okay, in this section, we are adding and subtracting radical expressions. And when we are adding or subtracting these types of expressions, we can only do so when they have like radicals. What that means is what's inside of the radical and the actual root of the radical itself all has to be identically the same in order for us to be able to add or subtract. Just like if you were taking variables, you can't add x squared to x to the third power and say you have, 2 x to the something. It doesn't work that way. So like term still applies when we have radicals. So we have 1 square root of 7 plus 5 square root of 7 minus 2 square root of 7. You really just take the coefficients and you add or subtract them. 1 plus 5 is 6. 6 minus 2 is 4. So this simplifies to be 4 times the square root of 7. Looking at letter B, we have different types of radicals. So we have square root of x's and we have cube root of 4's. So we're going to be basically just combining the like terms. 6 square root of x minus 5 square root of x. That's 1 square root of x. And then this is negative cube root of 4. Basically like negative 1 cube root of 4 plus 2 cube root of 4. Negative 1 plus 2 is 1. So this is going to be just plus 1 cube root of 4. That would be your final answer for those. So go ahead and pause, try the checkpoint. All right, going over the checkpoint, we have like terms right here. 3 cube root of x plus 2 cube root of x would be 5 cube root of x. And then plus 1 square root of x minus 8 square root of x, that would be negative 7 square root of x. All right, moving on to combining radical expressions when we have unlike radicals. When you do not have the same radicand, you are not able to add or subtract or combine them together. But these are designed specifically so that you can simplify to make them the same. So looking at letter A, we have the square root of 45x plus 3 square root of 20x. Well, what we would want to do first is simplify the radicals to see if they end up with the same thing inside once we do the simplification. So since we're talking about the square root, we're looking for perfect squares. Perfect square factors of 45 would be 9 times 5. So I'm going to rewrite this as 9 times 5x. Plus 3, I'm going to rewrite 20 as 4 times 5x. And as soon as you see that, you should see, they're going to have the same thing now. We can see the 5x will be left over. We're going to take the square root of 9 that comes outside of the root. So we have 3 times the square root of 5x plus we have a 3 here. And when I take the square root of 4 out, that's going to equal 2. And it gets multiplied with the number in front that was already there. So it's going to be 3 times 2 times square root of 5x, and that's really 6 times the square root of 5x. So we have 3 times the square root of 5x plus 6 times the square root of 5x. That's 9 times the square root of 5x. Looking at the second one, we still are going to want to simplify before we do anything else. So looking at the cube root of 54, y to the 5th plus 4 times the cube root of 54, y squared. First thing we have to notice is this is a cube root. This is not a square root. So we're looking for not the perfect squares that would be factors of 54, but the perfect cubes. Remember, to find perfect cubes, we take integers and we cube them. So this is going to be 1, 8, 27. And as soon as you get to 4 to the 3rd power, it's 64. It's larger than 54. So it's got to be either 8 or 27. Well, 27 is a lucky one because 27 is a perfect cube and a factor of 54. So I rewrite 54 as 27 times 2. And I rewrite y to the 5th as many pairs of y cubes as I can. Well, it would just be y cubed times y squared. Plus, might as well simplify this one, but we actually can't because 2 doesn't have any perfect cube factors and y squared can't be simplified either. So the the cube root of 27 and the cube root of y cubed can be taken out of the radical. The cube root of 27 is 3. And the cube root of y cubed is y. So outside of the radical, I have 3y times the cube root of whatever's left. We have 2y squared left, which works out perfectly because the other one is the cube root of 2y squared. So now we have 3y times the cube root of 2y squared plus 4 times the cube root of 2y squared. So they share these common things. Only thing with these is they're not like terms. So we have to write this as 3y plus 4 all times the cube root of 2y squared. We wouldn't just be able to write it as 3y plus 4 and then times cube root of 2y squared, because then it would look like it's only the 4 times the cube root of 2y squared, and it's the quantity, both of them. So it's almost like factoring out the cube root of 2y squared, and you would write it like that. You could also flip this around and write it as the cube root of 2y squared times 3y plus 4, and it would still be correct, but the standard form for any radical expression is usually to put the radical at the end of the expression. And I'm going to erase this so I can complete letter C. So this last one here is asking us to simplify. Basically, all of these are simplify. But I noticed that as soon as I see this problem, I have a radical in the denominator of that second fraction. So the first thing I want to do is rationalize that. And I'll do that by multiplying the second fraction by the square root of 7 over the square root of 7. Then I'll be left with the square root of 7 minus 5 square root of 7 over the square root of 7 times square root of 7 is the same thing as the square root of 49, which just equals 7. So basically the square roots cancel out when you multiply the two same things together. So we have here this expression. Well, this would not be the final answer, because we would want to try and simplify this as much as we can. And especially coming from chapter 6, we know that we can take these and hopefully combine them together into one fraction by finding a common denominator. So if we multiply this by 7 in the numerator and denominator, it turns into 7 times the square root of 7 over 7 minus 5 times the square root of 7 over 7. Well, then we can go ahead and make this into one single fraction. We keep the denominator the same, and 7 square root of 7 minus 5 square root of 7 would be 2 square root of 7 over 7. These two 7s do not cancel out. They're completely different numbers. Okay, looking at these two checkpoint questions, please pause the video and try them out. All right, so looking at the first one, this is square roots. Only thing I can do here is rewrite x to the third as x squared times x, and minus x times the square root of 4x. Well, actually, the square root of 4 can be simplified, but I'll just leave it like this for now. So the square root of x squared, I can take that out. It's going to be an x on the outside. And the square root of 4, I can take that out. And anytime you take something out of the radical, it gets multiplied by whatever was already there. The square root of 4 is 2, so I don't really like how I'm writing this backwards, but x times 2 will just get multiplied. So it's really like this expression. So we have 5x times the square root of x minus 2x times the square root of x. So what we're doing is taking these numbers and subtracting them. 5x minus 2x is 3x. So it's like having 3x times the square root of x. Number 2, we have here cube roots. So we're going to try to simplify these as much as possible. So the cube root of 6, nothing I can do with that, but I'm going to rewrite x to the 4th as x to the 3rd times x plus cube root. So we're going to rewrite this as 8 times 6x plus cube root, and then 162 by just quickly dividing this out by some perfect squares. 27 is a perfect square. So 27 times 6, x to the 3rd, x is how I would break these all up. Then simplify what I can. So first thing I can do with the first one is take the cube root of x cubed. Well, that becomes an x on the outside. So I'm left with 6x on the inside. Here, I can just take out the square root of 8, and that becomes a 2. So I'm left with the cube root of 6x. Perfect. It's lining up. Plus, it can be cube rooted, and so can this. The cube root of 27 is 3. The cube root of x cubed is x. So I have 3x times the cube root of what we have left, which is a 6 and an x. So perfect. What we have is x cube root 6x plus 2 cube root 6x plus 3x cube root 6x. So they share this common 6x. So what I can do is take the x and the 2 and the 3x, take all of those, add them together, and multiply that by their common cube root of 6x. Well, x plus 3x I can combine together to be 4x. So not 4x. Oh yeah, it is 4x. But so altogether it would be 4x plus 2 times the cube root of 6x. Please work on the exercises, and when you're finished, you can check the answer key.